We have discussed all three of Newton's laws about forces in class. In this video, I want to address two sources of confusion that arise when trying to apply Newton's laws. The first law is about equilibrium. If the sum of the forces acting on an object is zero, then the object is in equilibrium. That means that the object will have a constant speed. It does not mean the object is stationary. The object might be stationary, but a constant speed of zero is still just a constant speed. The second law tells us that when the sum of the forces acting on a mass is anything other than zero, the mass will accelerate. The bigger the force is and the smaller the mass is, the more acceleration there will be. The first two laws apply to a single object at a time. In any given situation, either one or the other is true. The third law tells us that forces occur in equal and opposite pairs. An agent exerts a force on an object. It is not possible to be your own agent. Here I am pushing a heavy box across the floor. It looks like the box is moving at a constant speed, yet clearly I'm applying a force to it. If I stop applying the force, the box stops. It is because of everyday occurrences like this that people have trouble with the second law. In most people's experience, they believe that the sum of the forces is mv, not ma. But that is because they're not thinking about the whole situation. It's not just my push that matters. Here's a complete free body diagram for that box. I must include the weight of the box, the normal force from the floor, and friction. Looking at this picture, it is clear when the box moved at a constant speed. The box was in equilibrium. Here is a buggy on the table. Its speed is zero. When I turn it on, it goes forward. It clearly accelerated. How does it do that? Many people are tempted to say things like the buggy pushes itself forward. But remember, the buggy can't be its own agent. When I turn the car on, the wheels spin backwards at the point of contact with the floor. What's really going on is that the buggy is pushing the floor backwards. The third law partner to this force is the floor pushes the car forwards. Many people are skeptical of this idea because they do not see the floor move backwards. That's because the floor has a lot more mass than the car. We can fix that. I'm creating an artificial floor that has very little mass. I'm placing the car on this tape to mark its starting position. Notice what happens when I turn the car on. The car goes forward, and the floor does go backwards. Actually, in this case, the floor goes backwards more than the car goes forwards. That's because the floor has less mass than the car. At any rate, Newton's laws always work when you apply them correctly. Sometimes your intuition will fail you because you have not thought about these things deeply enough. Well-drawn free body diagrams and forces described in agent-object notation will help you a lot with these issues.